What's going on, guys? My name is Hussein, and I usually do this uh, bit of news every time Postgres get released, but I missed it somehow. Postgres 13 was released September 24, and I missed it. Postgres is not making fuss about their releases. They just like tweet, we just released Postgres 13. No big deal. And they just move on. They need to make bigger fuss about this. I didn't know about this. For God's sake, I was using Postgres 13 without knowing because I was making my database introduction to database engineering course, and I was using Docker, and Docker by default posts the latest, and I was using Postgres 13 without even knowing. So yeah, that was pretty cool. So let's go through this. I usually go through the press release summary and then go through the matrix and then just scroll down and I try to explain whatever I understand. Obviously, I don't understand everything, right? So that's why I leave it to you. If anyone expert in database engineering or specifically in Postgres and you think some of these features you might benefit from, that would be awesome. How about we jump into it, guys? So Postgres 13 was released on September 24th. And there's a little bit some themes. It looks like they focused on performance gains in this release, minimum security features, and a little bit extensions and optimization when it comes to vacuuming, which is I throw this in under performance if you ask me. So in general, they made improvement when it comes to vacuuming specifically, like parallel vacuuming for indexes. And what I liked about this is you can use they are using now multiple threads to vacuum bad indexes, and this is enabled by default. You don't have to do anything, right? So Postgres, guys, if you update anything, if you don't know, if you update or delete anything, the index still points to this dead row, right? So there is you're gonna start seeing this did tuples all of the time, and the cost of reading the index with a did tuple can be, if they are a lot, can be a little bit deadly, right? Because you're reading this and then you're gonna find out it's dead. It's Postgres knows it's dead, but the cost of reading it while finding out that it's dead, that's expensive. So vacuum usually clean this up. If you do vacuum full, I believe that's what you call it, which I believe does an exclusive log in this, right? It will do all of this stuff for you. If you do normal vacuum, that also cleans up the indexes in a parallel manner. So that's pretty neat, I think. Incremental sorting, all this. This is apparently this I didn't know what this is. Incremental sorting. It's actually a new sorting algorithm apparently that Postgres implemented. So I had to Wikipedia it. So there is like partial sorting, and there is this incremental sorting, which apparently does things much faster. Another performance gain, data duplication, deduplication of B3 indexes. So guys, like let's say you have this is what I created on my course, right? I had a table with grades, right? So and the grades were an integer, and their name, field, and then grade. And the grade is like from 0 to 100, and grades are doomed to be duplicated, right? So in this case, if you create an index on the grades, you will have multiple entries in the index that points to the same exact value, but they are different rows, right? So today in Postgres 12, what they did is every index every entry in the index points to that row, right? So to that table in the row. So if you have like, I don't know, let's say the grade 70, and you have like 100,000 of those, so you're gonna have 100,000 of those entries, right? And they are organized in that way. But what they fixed in Postgres 13, or they enhanced, is they made a single entry with an array of row IDs, or I think they call it TIDs, right? Which points to the table, which is pretty efficient. So they deduplicated this data. So instead of duplicating these values, the 30, the 30, the 30, 30, 30, 30 all the time, they just basically have one, or 70, 70 in our case. They have one value and then on that, right? They made all of this stuff. So pretty cool. They made a pretty good enhancement to partitioning, which is pretty neat. Partitioning, if you don't know, guys, is the idea of splitting the table either by range, by list, or by hash into multiple tables. So it is still, to you as a user, it's a one table, but behind the scenes there are multiple tables, and you can access those tables if you would like to. And the trick here is they fixed some performance paths where they were accidentally scanning multiple partition unnecessarily. So they pruned, they call this pruning. They pruned these partition to focus on only things they need absolutely to scan, which is very, very, very important. So partition pruning has to be enabled by default. Some administrative stuff, parallel vacuuming, we talked about that a little bit. Write ahead logs, improvements, and yeah, some stuff. Yeah. So here's the matrix, guys. So if you see, this is the matrix. You can see the gradual values 9, 5, 9, 6, 10, 11, 12, 13. And you can see anything that has a yes in it here, that means it just introduced this release, right? While it says no, that means it wasn't introduced in Postgres 12. So you can see that explain wall support. So now you can actually explain with the option to do a write ahead log. So how about we actually demo this stuff, right? So let's clean this up. And write ahead log only shows up when you actually write, right? So if I do explain let's do this. Analyze true, write ahead log true, and I do insert into, I don't know, I have a grades table here, I think. Let's say name, or I don't know what's null. I think it's just a good G values, I don't know, 10. If I do that, you can see that the wall write ahead logs record 2. I forgot what this stands for. Images, something like that. I forgot what stands for, and the number of bytes required for that. If I do it again, this goes down. It's just I don't know how exactly Postgres does this, but this is now more information for you to look at, which is pretty cool. Write ahead log. Inserts data can trigger auto vacuum, which is also pretty neat. And the idea of here's the thing, guys. So I might say, hey, I'm inserting new data. Why I need to vacuum a table, right? Because why would we need to vacuum in Postgres to begin with? When you update a row or delete a row, that row is orphaned and a new row is inserted, right? And that when you vacuum, those bad entries, those dead tuples are just removed physically from the table. Well, it depends. It depends if you do full, which is physically removing it from the page, or vacuum, which is just marking them as bad. So when you insert, these are just new stuff, right? So nothing to clean up, but Postgres is a multi-version concurrency control system, so that if you insert a row and there are isolation, we talked about isolation many times in this channel, right? Check out the video right here, ACID. So if I insert a new row and there is an existing transaction that is running, that transaction should not see my row because I inserted it in another transaction, right? Unless it's committed, right? As long as I didn't commit, if I inserted, this transaction is still running. So it needs an isolated lens. It needs to see its own stuff. If that old transaction saw my row, that's a dirty read, right? Bad idea. So Postgres sets these values that says, okay, this row existed from this transaction ID, and it's still alive, right? And the old transaction ID, obviously, when you start to read information, if you want to read that row, Postgres does some magic. It says, okay, I am a transaction. I'm about to read. Am I allowed to see that row or not? It checks if my transaction ID is older than this transaction that this row was created in, I should not see it, right? Else, okay, I should see it. So this check, if check, that is extremely expensive because we have to go and that select statement can actually change the state of the page to being saying that, hey, by the way, this row is actually now visible, and there are no transactions that are alive currently beyond the existence of this row. So this row should be visible. So we don't need to do this stupid check anymore, right? So that the act of selecting that row triggers, funny enough, triggers a write to the page, which then, if you do it so many times, if you're inserting so many rows, then you're doing these selects. The first select will trigger a lot of writes, and that will slow things down. Because if you write, you need to, if you write anything to the disk, right? If you write to a memory, you have to write it also to disk, which creates I/O, which is weird, right? I'm selecting. Why is this writing? So to avoid this, people told us all the time, after insert, always run full vacuum or at least vacuum, so that because no other transaction. I'm doing bulk loading, right? No one is connecting to the system and doing reading as I'm doing this stuff, right? So there is no isolation, there is no any of that stuff. So just let everybody know that all these pages are visible. So hopefully I didn't screw this up and I did this right. What do Postgres says? The new behavior reduces the work necessary when the table needs to be frozen and allow pages to be set as exactly. It allows pages to be set as all visible. If you read this, you will be very confused, right? The page as all visible means, hey, there are no all transactions that need to be isolated from this. It's visible to everybody. Make it visible. So vacuum does that. So Hussein, what are you doing now? What's this feature? Inserted data can trigger auto vacuum is a new feature that after insert, an auto vacuum will be triggered, which is very useful because for people who don't know to vacuum their table after insert, Postgres 13 is pretty neat, right? And you can configure how many rows you want and all that stuff. Pretty neat, right? Okay, for example, trigger an auto vacuum after 1,000 rows. Trigger auto vacuum after, I don't know, this much, right? Which is pretty neat. Parallel vacuums for indexing, for indexes. So you can vacuum indexes in parallel, which is pretty neat, right? So it's faster, right? Because vacuum prior to this was, I guess it's a single threaded. And it's hard to vacuum in parallel, man. Just the work required to do this, man. And I think you can also configure how many threads you want to Postgres to do this stuff when it does this thing. So it's pretty neatish stuff. Pretty neatish. Cool, very cool stuff. So yeah, parallel indexing. So I bet this is gonna go with a lot of bugs for some reason. I have a feeling. Let's scroll down. What do we have? SQL JSON. So this is Postgres attempt to be to pretend to be a NoSQL database, which I don't really. I don't know why Postgres just stick to being a relational database. Trying to like, it's like MongoDB trying to be as a database. Just stick to what you do best, right? Just Postgres. I disagree with this. You're wasting. Why would I pick Postgres to store JSON values like? And then you're gonna start supporting search on JSON. I think they did already. So this is now datetime. They just added the function datetime to JSON for some reason on SQL. Or am I wrong here? Let's see, what is this? The SQL JSON path. Yeah, that's the path thing that they invented. I mean, let me know, guys. What do you think about Postgres implementing these JSON features? Do you find it useful? Or do you think Postgres just doing too much and they should focus on performance and other stuff? Let me know. I would like to see your opinion. V3d Duplication, we just talked about this, right? So now you can actually, in a B3, this is a very, very good read. I'll leave all these links below for you guys. So deduplication is the idea of, like, as we said, we have We have a table that has duplicate values by default, but those rows are unique, obviously, right? Because every row is unique. Like student Ali and student Roger have both gotten 80 grade, right? So if you get an index on grade, you have two values 80, but how do you present them in the index? That's the trick. So they saved they by doing deduplication, they minimize the index size. And guys, if you minimize the index size, that's the best thing you can do. Why? Because now if your index, for example, went from 1 gig to 500 meg, or from, if it's too big, it went from, like, I don't know, 5 gig or 20 gig to 3 gig, you can fit it in memory. And when you fit it in memory, you can do memory scans. If you have only index only scans and your index fits perfectly in memory, you're just CPU bound. I mean, it's not really a big deal if you have a good, powerful CPU, but then you're unstoppable, man. If you put your entire index in the memory, that's the best thing you can do. If your data and the index does not fit in memory, then the purging system will start doing all this stuff, like a paging to disk, and because you're treating the disk as memory, and then you can see spikes in I/O and stuff like that. And if you have an SSD, God knows what will happen with there. Yeah, SSD is gonna be faster, but I think it's gonna reduce its life with time. If you're writing and reading to disk, SSD can only have a little bit limited number. Fetch first with ties. This is actually a new SQL standard. It used to be called limit. Guys, when you remember, it's like, oh, select star from this table, limit 7. Give me only the first 7 rows. And if you want to do, you can do offset 0, limit 7, right? Give me the first row starting from, give me 7 rows starting from row 0. And if you select, for example, select star from grades, where or limit 100, no, offset 100, limit 7. That means start from row 100 and give me 7 rows. So this is very, very powerful feature for paging. If you want to page stuff, right? Like give me this page and then this page. Like if you have an app that selects, okay, give me this page from 0 to 100, then you go next page. Obviously, when a web application, that's very tricky to do, because how would you know if your application is stateful? This is the best, right? But if your application is stateless with HTTP, then the next call, HTTP call, to fetch the next page, like let's say I'm gonna fetch the first page, right? You do this query, right? Limit 0, whatever, 10 rows, and then the next call. So the database took the hit and queried the table, but it stopped in this limit after fetching 10 rows. However, if you want to fetch the next one, you got to do it all over again, right? Because that next HTTP GET call will hit a completely different process. It's not going to hit the same process. It's not going to hit the same server, especially if you have a reverse proxy or load balancer. It's going to hit a completely different server. And if it hit a completely different server, you're going to have to execute the same exact query again. And if you don't pool, you have to execute the same. You have to establish the TCP connection with the Postgres database to begin with, and then follow up with a query, and then do this query again to go to offset 10 or offset 11 page limit 10, right? So that's why people now are putting layer 4 proxying like Envoy and Traffic and HA proxy on top of their Postgres and MySQL databases, so they can be a little bit stateful when it comes to paging. So only in certain situations, like, hey, if I can benefit from a stateful app where I can point my data, my queries onto the same process that has this cache data already, let me do it, right? So we didn't talk about this feature now. Fetch first with ties. So fetch first is a replacement apparently for this offset limit, right? And they just implemented the with ties option. And with ties is basically if you do an order by, and let's say you're give me the first 10 rows, right? And the last row, the grade is, let's say, 90, right? But the next row after it is also 90. So this is called a tie, right? Because that last row, okay, if you want actually both of them, like I said, I don't know, you want to announce a winner and with tie, right? So that particular last row is give me all the the first 10 rows with ties. That means the last row, if there are like another row that exactly equals it, the same value, returns it to me, even if it's 1 or 2 or 3 or 4. Give all the ties back to me. So that's what it means. I have never had to use something like that, but when I read it, it's like, okay, I guess I understand. No new DDL work for Postgres 13. Actually, no new DDL work since Postgres 11. I guess it's feature complete, huh? The last thing they did was create access method. So I mean, yeah, I guess. Reindex concurrently was done actually in Postgres 12. I spoke about that in my old video, in the original video. Yeah, that was a pretty neat reindex concurrently. It's pretty neat. It creates, I think, you can reindex concurrently without actually locking the table, which is wow. It's pretty neat. Create statistics, some statistics stuff. Hash aggregation can use disk. The planner can now, instead of doing planning, if you're doing aggregate like a group by or count or stuff like that, max, which hash aggregate can create a table, temporary table. It used to be only on memory. Postgres 13 now allows you to use disk if the aggregate is so big that doesn't fit in memory, right? I don't know. Was it if it didn't fit in memory? Were we getting an error before? Let me know if you guys use any of this stuff. Incremental sort, again, we talked about this a little bit. But yeah, guys, this is it. Security, some security stuff. Apparently, it's Postgres now is doing authentication for certificate, which is pretty neat. Some extension stuff, and yeah. All right, guys, what do you think of Postgres 13? Do you think it's a big release? I don't actually think it is, but I think these features are really hard to work with. Really hard to build, in my opinion, if you ask me. But I'll leave this opinion to you. What do you guys think? Let me know in the comment section below. I'm gonna see you in the next one. You guys stay awesome, and make sure to subscribe for more back indie stuff and discussions. We have a lot of fun discussing this stuff. Check out the other content of the channel. I'm gonna see you in the next one. You guys stay awesome. Goodbye.